So I'm David Guest. I'm a solution architect and technology evangelist, which means I do a lot of talking. We've had a few illnesses in the camp recently, so we did think I was going to actually do all day, so I'm really glad that Andy's still here and is talking. Otherwise, I would be absolutely dead by tonight. I'm going to talk to you a bit about global secure access, and it's probably going to give us a lot of questions. To which I may not necessarily have all of the answers, but any questions I can't answer, I will take back to Microsoft and we will get answers. Need to correct this slide. I did Andy's earlier, I forgot to do mine. What's the mistake? Borders. Yeah, I can just imagine now you've got a guy on a skateboard who's in your network taking it on. But we know these things have happened, and traditionally the way we've got around this is by allowing people onto the inside. And once they're on the inside, we've got them, they're contained, and we allow them to do whatever they want. Yeah, that's not necessarily always a good thing. So we need to be thinking about this and how we can actually get better at giving people the access that they need. So we've got these wonderful things that we're all using, cloud applications, we're using our identities. Just as a question, and it's not a poll, you don't have to go into Slido, how many people here use Google to provide their cloud identity to non-corporate stuff? How many people use Apple to do that? Have you noticed my hand hasn't changed yet? How many people use other services to do exactly the same thing? Yeah, look, I've got a problem here. My hand's stuck. And is this because I'm stupid? No, it's because not everybody supports Google or Apple or Microsoft or LinkedIn or all of these other things. And this identity piece starts to become really complicated, particularly when we talk about verified identity. If you want to know about that, go and see Marcus's session this afternoon, which will go into verified identity in some detail. We've got all of these devices. As Andy said, I remember a time when there was no smart device. The closest you got was a BlackBerry, which was great for sending and receiving emails, as long as you didn't have too big a thumb, because typing on it was a pain. We've got this data, it's all moving around. We have to be aware of where it is and what it is. There is a great statistic that Microsoft use, which is that 83% of IT do not know what their data is. I actually think it's worse than that. 83% of corporations do not know what their data is, let alone where it is. Anyone here do local government, police, anything like that? You know, there's bound to be some around. So we know that we have official sensitive, public, top secret, bigot, and lots of other things. Can anyone actually describe the difference between them? It's really difficult. And if you can't do that and you're using something that's mandated by government, how on earth is the poor person in a call centre going to understand that the document that they're typing up in Word is official, sensitive, top secret, or something else? So being aware of what your data is and where it is starts to become really important. And then we need to think about what's happening with that data and where it is and how we access it. The idea that somebody can just go onto a browser on their home PC and sign into your Salesforce instance because they know their ID and password is possibly something we should be worried about. When somebody signs into Salesforce and they go to your sales leads and they go download, is this something they should be doing? How do we control that today? Well, quite often we'll put in a CASB, so a Cloud Access Service Broker. Or you'll put a proxy in, or you'll put some session controls in, or you'll just block Salesforce completely. Well, these are all good answers, but here's another one. We can use a secure service edge, a SASE, and we can make sure that you are driven to use that whenever you go to Salesforce. And we do that by making sure that you sign in using a common identifier. By common, I mean common to the business, not common to the user. It's not a generic account, it's their account. So I sign in to Salesforce as david.guest@cocho.co.uk. You can quite happily have my ID. It's my email address. You all know it anyway. What you don't know is my password. And of course, my password is easy to do because it's a common word, or two, or three. Or actually, maybe it's the first line of my favourite song, or maybe it's my favourite football team, which, by the way, has appeared on the screen at a number of these events because I forgot to turn notifications off. And you can get it that way, and you might be able to socially engineer it, but you won't be able to do the MFA because that's in my pocket. And if I don't recognise the fact that I'm signing in, I'm not going to say yes. I'm not going to put those 2 digits in that are on the screen that I can't see. So we're keeping it safe. And using the internet access as part of GSA allows us to maintain that security. And it's a really, really nice way of doing things. We basically, as you hit the entry point to the secure access, we check who you are. And as you hit the exit point from secure access to go to the service, we check who you are. And if something's changed, we're going to check you again. Oh, and again, and again, until you get so fed up, you're going to go away and hack somebody else. But we're also going to do this for private access. And private access is actually where the risk really sits. Because traditionally, how do we gain access to our internal network? We have that wonderful thing called a virtual private network, VPNs. Don't we love them? Aren't they superb? And once I've signed into the VPN and I'm on the LAN, what can I do? Actually, more to the point, what can't I do? I've got an open connection. If my device happens to have been infected by malware, well, so's the network now because I VPN'd in. And we have no control over that. Well, that's not quite true. We can put you on a separate LAN. But because you've got access to the servers, what's the point? I'll infect the server. The server will then spread, and actually all of the LANs will get it. So VPNs aren't necessarily as good as people think. What we want to be doing is providing a better support. And as you come in, okay, let's check who you are. You're David Guest, okay? Your job is a solution architect. That means you can't RDP onto a server. You can't run SSH, but you can get onto a file share. But you only have read access because your device isn't compliant. So you can't write anything. These are the sort of controls we can put in. Oh, you're David Guest, the admin account, which actually is just david.guest2, because we don't make our admin accounts obvious. We don't put admin in front of it, or X or Z or something like that. We hide it in plain sight. But because you're an admin account, actually now you can run SSH. I will open that port for you. But you're still not doing RDP because that device still isn't compliant. So we've got all of these extra controls. Now this is the Microsoft diagram that explains how it works. We start off on one side with somebody on a device somewhere, and we enter the Microsoft... Sorry, no, I prefer my one. We've got a user, whoever he happens to be. He wants to access something, so he'll enter the tunnel. As we enter the tunnel, we are authenticated. If we are authenticated correctly, we get onto the Microsoft backbone. The Microsoft backbone takes us to a point of presence close to wherever we're going, whether that's Microsoft 365, Salesforce, or on-premises. We then come out of another tunnel where we get checked again. And if that's good, we get access to the services. And the services can be anything at TCP or UDP level. Anything. Now, some of these things don't quite work properly today. We've got a few people in the room who I know are testing this stuff out. And some of the domain access isn't the way we'd like it to be. Some of the DNS doesn't quite work the way we want. But we're still in preview. This is not due to GA this month. But when it does, you can guarantee these things will be fixed. There are plans to make sure that your Kerberos authentication and potentially header-based authentication to internal services will still flow through this, even if you're on premises, sitting on the LAN on a cloud-only device. It will still allow you to do the connection. The best thing about that is it won't trombone. It won't go out to the internet to come back in. The connector will say, oh, hang on, you're local. Just go direct. And it saves all of that traffic and noise. So we have the tunnel. And I have to think of the tunnel as having some kind of security on it. So we have something there. This is what we've been using for years. It's conditional access. Who are you? Where are you going? What device are you using? If you can answer those and provide me with authentication strength, so I want a FIDO key, then I will let you in. But if you can't do those, no, I'm going to turn you back. We're going to refuse you access. 10 minutes left. We're good, we're good. So, how would you like a demonstration? Now, I have, sitting at home, it's actually a 10-year-old laptop that has on it a few bits and pieces that I can share across the internet. Well, actually, I can't, because it's not an internet connection, is it? It's a home broadband. Why would anybody share a server across a home broadband? I mean, yeah, daft things to do. So, but this is what we've got. I've got an Active Directory. I've got a website. The website's sitting on a separate server on the same laptop, but it's a separate server. And I've got a joined laptop. It's running as a hybrid, Azure AD, Entra ID joined device. And I'm sure I'm not the only one who still can't get used to saying Entra ID joined. And we're going to use that to connect to the environment. And I'm going to do it using GSA. I'm going to do it using a direct validated connection from the device. Now, as you can see, my laptop is not on stage. And the reason for that is I recorded this earlier. This is a Blue Peter moment, for those of you who are old enough to remember Blue Peter. So, here we go. First of all, I'll go to the website. And I'm going to the website on a network where the website doesn't exist. And what do I get? Okay, I'm getting redirected to my ISP. And yeah, that's not going to work. But if I go to the intranet version, you may have seen up in the top, it for a second prompted me to log in with my Azure credentials, my Entra ID credentials. So I got my web page. I'm then going to go to google.co.uk. Now, this one didn't quite work properly because although it's blocked, I didn't get a very good message. But when I go to play, I get the right message. That's useful because that's telling the user, I'm sorry, you can't go here, and I've blocked you in the right way. If I go to play.google.com, I can get through. So I'm being very specific here with the internet access piece and stopping people from doing things. But google.com is fine. So we can start to be very clever. I will allow you to go to salesforce.com. That's not a problem. But I won't allow you to go to salesforce.com/cocho/sales/leads/whatever you want it to be. Because I don't recognize where you are. So we can start to be really specific about how this works. Now, that's all very well and good, but what didn't that do? Did anyone see any MFA? No. That's because there wasn't any. So, let's do it again. Just checking, this is the Global Secure Access client. This is how it's set up. This is what it does. This tells me all about it, tells me that it's actually working. We've got all of the information, including the device is Entra joined, so I can get the information I need. We can have a look at the profiles for where I'm going and what I'm allowing. And you can see here I've got rules for Microsoft 365, I've got rules for private, and I've got rules for intranet. And in there I've got google.co.uk, which is actually blocked. And it's done through a tunnel. So this is how we can do the controls. And this actually is how you do the fault fixing later. We've got hostname acquisition, so we can actually see what's going on. Before anybody asks, the IP address that this uses to identify the device is the IP address of the device. So I use BT as an ISP, so my actual address is 86 dot something. My device address is 192.168.1 something. Don't actually know what it is because it's DHCP. The address that GSA uses is the 192.168 address, not the ISP address. So we can again start to be very careful about trusted networks. We actually can define corporate networks by their internal IP address, not the external IP address. So you can decide that if somebody is on a corporate network, they can gain access to the services directly without having to do the MFA. We'll then turn conditional access on. I'm sure you're all familiar with conditional access policies, but we have the intranet app. This is my new app. This is the one that I want to protect. So we'll turn that on, and I'm going to say you must do passwordless MFA. It's not good enough just to do MFA. It must be passwordless. Okay, starts to make it a bit dangerous. So here we go. From My Apps, we go to the application, which is the intranet application. It launches the browser and it asks me to sign in. Please remember passwordless MFA. I put in my password. Sorry about the screen things there, but look, it's now asking me to provide a PIN. And this is a PIN for Windows Hello for Business on the device. That is passwordless. As soon as I put the PIN in, I get to my web page. And that's authentication strength at its best. We also, at the same time, have the ability to do a thing called continuous access evaluation. Anybody know what that is? Okay, this is good. It means I can talk for another few minutes. Continuous access evaluation. Okay. If a user has logged into your system and their password changes while they are logged into the system, is that a risk? Well, it should be a risk. Now, at that point, what would you like to happen? Should we just let the user carry on regardless? Or should we say, actually, something's happened here. You've changed your password. I'd like you to redo your MFA. Now, that's where continual access evaluation comes in. It sees the password change. It sees your location change. It sees your IP address change and uses that as a trigger to redo the conditional access. And of course, when we redo the conditional access, we're back to using authentication strength. And because we're using authentication strength, I still need to do my passwordless MFA. So it's back to me putting in a PIN on my device, which opens up the certificate store and passes the right certificate to the service. It's a brilliant way of working, and continual access evaluation is one of the key cornerstones you should have around your zero trust network and zero trust access.